Thanks, friends. In this module, we are going to see chemical analytical methods. Chemical analytical methods are generally used right from our schooling college days. We know these methods very well if you recap what you have done in your school or college days, like salt identification, titrimetric methods. So these chemical analytical methods are now also being used in pharmaceutical industry in a little scope, with a little scope for the few of the drug molecules, and it is still one of the cheapest preferable method for few drug molecules. So let us see briefly about these chemical analytical methods in this module to understand to what extent it is being used in pharmaceutical industry. What is chemical analysis? Chemical analysis is a chemistry used for determination of the physical properties or determination of a chemical composition of the sample of matter. So we are going to determine either the physical property or the chemical composition. Either it is a qualitative, that means identification of a chemical substance, like what we did in your college days, like salt identification, or quantification of the chemical or complex substances. That means your assay doing by carried out by titrimetric methods. So quantification of the chemical is being done by different titration methods. Also is a chemical method. Then finally the chemical methods can also be used for separation of chemical species. In this slide, we are going to see some of the examples of identification of the chemical substances or how a chemical method used for the qualitative analysis. The classical example is identifying presence of chloride ion in water. When you add silver nitrate solution with water, it will form a cloudy precipitate coming out of the chemical reaction, and the precipitate is nothing but the silver chloride. So that you are confirming the presence of chloride ion in the water. Similarly, you can also confirm the presence of ferric ion in water by adding ammonium hydroxide solution, which forms reddish brown precipitate, which confirms the presence of ferric ion in water. Now we are going to see what are quantitative chemical analysis methods. A classical example of quantitative chemical methods are titometric analysis. What is titometric analysis? It is a method of quantitative analysis based on the measurement of the volume of a solution with a precisely known concentration of a reagent. That is the titrant required for reaction with a given amount of substance being determined. That is the analyte. So now we will see what are the different types of titrimetric analysis in the upcoming slides. The different types of titrimetric analysis are acid-base titrations, which we have done during our pharma college days. If you are a pharma student, you might have done this in your chemistry laboratory analysis. And complexometric titrations, precipitation titrations, oxidation reduction titrations, then non-aqueous titrations. Now we are going to see in detail about acid-base titrations. What is an acid-base titration? It is a method of quantitative analysis for determining the concentration of an acid or base by exactly neutralizing it with a volumetric solution of base or acid having a known concentration. A pH indicator is used to monitor the progress of the acid-base reaction. In addition to this acid-base titration, you can determine the molarity as well. How? If the acid dissociation constant of the acid or base dissociation constant of a base in the analyte solution is known, its solution concentration, that is the molarity, can be determined. Alternatively, the pKa can be determined if the analyte solution has a known solution concentration by constructing a titration curve. So it is not commonly we have done in our laboratory during our college or school days, but the first part, the acid base titrations with the pH indicator, is the common analysis method employed for assay of several compounds, several drugs present in the finished products, which we have seen in our experience right from the school, college to the industry. In this slide, we are seeing some of the types of acid-base titrations. So the strong acid, weak acid, strong base, weak base combinations can be used for acid-base titration. So some of the examples of this combination we are going to see. Strong acid, strong base. You can use hydrochloric acid and sodium hydroxide for the titration. Then in case of weak acid, strong base, you can use ethanoic acid and sodium hydroxide. Then it comes to a strong acid, weak base, you can use hydrochloric acid and ammonia. Then weak acid, weak base combination is nothing but ethanoic acid and ammonia. So this is how the combinations are being used for different types of acid base titrations. And whatever the types of acid base titration we have seen, it uses the pH indicators. So what are the choice of indicator for each combination? For a strong acid, strong base, we can use phenolphthalein, which used to see the color change. Then for a weak acid, strong base, again you can use phenolphthalein, which is a good choice to see the color change at the equivalence point. Then for a strong acid, weak base, methylene orange can be used. And for a weak acid, weak base, we cannot use phenolphthalein or methyl orange. So here no indicator is suitable because it requires a vertical portion of the curve over 2 pH units. We have seen the combinations used for the acid-base titrations. Amongst these combinations of different acid and bases, the weak acid and weak base combination is not at all can be used for the pharmaceutical applications because no indicators can be used in that particular combination. So other combinations like strong acid, strong base, strong acid, weak base, strong base, weak acids are being commonly used acid-base titration methods in determination of assays or some other applications in pharmaceutical industry. Some of the classical examples of these acid-base titrations in pharmaceutical industry is the salicylic acid assay, aspirin assay, and some of the acid neutralizing capacity assay of antacids. This is the most commonly used applications of acid-base titration in determination of assay of active pharmaceutical ingredient in the finished product, or directly you can assay the active pharmaceutical ingredient when it is available in the form of API. Next type of titrimetric method is complexometric titrations. Complexometric titration or chelatometric titrations is a form of volumetric analysis in which the formation of a colored complex is used to indicate the endpoint of a titration. Complexometric titrations are particularly useful for the determination of a mixture of different metal ions in a solution. There are different types of complexometric titrations. In this complexometric titration, EDTA is the most commonly used chelating titrant. What is EDTA? EDTA is ethylene diamine tetraacetic acid. So EDTA can be used as a chelating titrant in many ways. So EDTA titrations can be performed by following methods. These methods are the types of different complexometric titrations. There are direct titration, indirect titration, back titration, and replacement titration. Let us see one by one. In case of direct titration, the standard titration standard EDTA solution is added to give sample containing metals using burette till the endpoint is achieved. Copper, barium, zinc, mercury, aluminum, lead, bismuth, chromium, etc. are metals that can be determined using direct complexometric titration. So we are directly taking EDTA solution in the sample containing metals in the burette, and we are adding this EDTA solution till the endpoint is achieved. So this is direct titration. And in case of indirect titration, some anions form a precipitate with metal cations. These anions do not react with the EDTA. So these can be analyzed by indirect titration with EDTA. For example, barium ions can be determined by indirect titration. What is back titration in complexometric titration methods? We call it as back titration. In this titration, we perform back titration of excess amount of EDTA. So in this, an excess amount of standard solution of EDTA is added to the metal solution being examined. Then the excess amount of EDTA is back titrated by the solution of the second metal ion. Next is the replacement titration. It is used when direct titration or back titration don't give sharp endpoints. In this titration, the analyte containing metal is added to the metal EDTA complex. The metal present in the analyte displaces another metal from the metal EDTA complex. The commonly used metallochromic indicators are calcine, curcumin, eriochromic black tea, fast sulfone block, etc. Complexometric titrations are being used widely in the industry, including the pharmaceutical industry, chemical industry, etc. For some examples of the applications includes, it is used for the estimation of the amount of total hardness in water in terms of measuring the metal ions in the water, and it is used widely in the pharmaceutical industry to determine the metal concentration in the drugs. For example, calcium assay. And the use of titanium dioxide in cosmetic products is analyzed by complexometric titration. Next type of titrimetric method is precipitation titrations. The third titrimetric method we are seeing. Precipitation titration is a type of titration which involves the formation of precipitate during the titration technique. In this, the titrant reacts with the analyte and forms an insoluble substance called precipitate. It continues till the last amount of analytes is consumed in the form of precipitate. For example, we have seen this example already in case of determining the chloride content in water by using silver nitrate solution. So when the silver nitrate solution added to the water, it forms the silver chloride precipitate using the silver ions. In this kind of titration, one of the classical indicator used is the dichlorofluorocene. Precipitation titration also widely used in the industry, including the chemical industry, pharmaceutical industry, and other types of industries. The classical example, what we already seen, the presence of chloride ion in water can be determined using this method. And also, the salt content in the food, beverages, and water can be determined by this precipitation titration method. And drugs like potassium chloride infusion, sodium chloride infusion, etc., can be assayed using precipitation titration as well. And also, this method can be used to determine the concentration of anions in the analyte. Now we are moving to the widely used titrimetric method, that is oxidation reduction titrations, redox methods. The term oxidation reduction can be defined in terms of adding or removing oxygen to a compound. Oxidation is the gain of oxygen, reduction is the loss of oxygen. Both reduction and oxidation are occurring simultaneously in this method of redox reaction. In case of redox titrations, the indicator action is analogous to the other types of visual color titrations. In the immediate vicinity of the endpoint, the indicator undergoes oxidation or reduction depending upon whether the titrant is an oxidizing agent or a reducing agent. Classical examples are potentiometer or conductometer, which is used to find the endpoint. Redox titrations are widely used in pharmaceutical industry and other industries, and the applications include the assay of ascorbic acid, ferrous fumarate, ferrous gluconate, and complex compounds like ion dextran, ion sorbitol. Now we are moving to the final last method of titrimetric assay methods or titrimetric analysis is non-aqueous titrations. This is a type of titration in which the analyte substance is dissolved in a solvent which does not contain water. Because water can behave as a weak base or a weak acid as well, and can hence compete in proton acceptance or proton donation with the other weak acids and bases dissolved in it. So we are going to use a solvent which is not in the nature of water or it does not contain the water. So non-aqueous solvents are being used in these titrations. Various types of non-aqueous solvents can be used for the purpose of non-aqueous titrations. Those include aprotic solvents, protophilic solvents, protogenic solvents, and amphitropic solvents. What are aprotic solvents? These solvents are neutral in charge and are chemically inert. They also generally have a low dielectric constant. Examples are chloroform and benzene. Protophilic solvents are having a basic character and tend to react with the acids they come in contact with and leading to a formation of solvated protons. Examples are ammonia and pyridine. Protogenic solvents, which are having a more acidic character and tend to have a leveling effect on the bases they come in contact with. Examples of these protogenic solvents are sulfuric acid and acetic acid. Then finally, amphiprotic solvents. These solvents have properties which are protophilic as well as protogenic. That's why it is called amphiprotic. Examples of the solvent acetic acid and alcohols. For many titrations, the endpoint can be detected by electrical measurements by potentiometric analysis or by using the indicators. So potentiometry can be done by a specific instruments, and the indicators used in non-aqueous titrations are crystal violet, Oracet blue B, quinal din red, thymol blue. These are the indicators can be used for the non-aqueous titrations. In this slide, we are going to see some of the classical example of titrants used in the non-aqueous titrations. For example, perchloric acid in acetic acid is one of the titrant used in non-aqueous titrations. Other classical examples includes potassium methoxide in toluene, quam ammonium hydroxide in acetonitrile or pyridine. Non-aqueous titrations are widely used titrimetric methods in pharmaceutical industry for the determination of assay or purity of the drugs or chemical compounds. The drugs which are include phenobarbital, steroids, diuretics, tetracyclines, etc. and other drugs like bisacodyl, chlorpheniramine maleate, nicotinamide, pyrimethamine, trimethoprim, etc. can be analyzed by non-aqueous titrations. Though advanced analytical methods are available today to determine these compounds for the assay and purity, still we can use these non-aqueous titrations to determine the assay of these compounds. This specific slide showing the calculation of assay method using the titrimetry method. This is the commonly used formula. So the assay percentage purity will be calculated using the titer volume multiplied by normality of the titrant multiplied by equivalent factor multiplied by 100 divided by weight of the sample. So the normality of the titrant is equal to the number of gram or mole equivalents of solute present in 1 liter of the solutions. Equivalent factor generally is equal to molecular weight divided by the valency. So this is how the assay of the or purity of the specific drug in a formulation or directly the active pharmaceutical ingredient can be determined by using the titrimetric method. So aspirants, in this module we have seen widely used chemical analytical methods including the qualitative methods as well as the titrimetric methods, different types of titrimetric methods used in the pharmaceutical industry as well as the other chemical industries, food industry, etc. Thank you.